All right, here we go. Okay, so we are going to be learning intro to trig. Now, you guys learned this a year ago, and um, yeah, this is kind of like review. So we're going to be reviewing for the next 2 days. So right here, you guys have a triangle. Okay, so this y value, this is y, because y represents like height, right? This is x, represents like the x values, and this is r. So the reason why this is called r, you guys, is because this triangle could be part of a circle, and this would be like the radius of a circle, but we'll get into that later. Okay, so we have three trigonometric ratios that we are hardcore going to be looking at, and that's sine, cosine, and tangent. Okay, so those are ratios of the legs and hypotenuse lengths. Okay, and I think a lot of you remember it from SOHCAHTOA from last year, which is this right here, SOHCAHTOA. So S is the sine, right? And then O and H is the opposite over hypotenuse. This C is cosine, and the A and H is adjacent over hypotenuse. And this is tangent, and that represents opposite and adjacent. So we'll begin with this. So you guys see that right there? That is what you call theta. So I'll draw it. It looks like this. So usually, we represent like length and stuff using variables such as x and y. Theta, you guys, that theta, that is represented like that's a variable for angle measurements, okay? So that's like an angle measurement and it's called theta. So when we look at SOHCAHTOA, when we calculate sine, that is the ratio of the opposite side to the hypotenuse. So for example, and I did teach some of you guys last year in this. So when you guys have sine of theta, you have to think in the perspective of the angle measurement, okay? So you have to, whenever you see theta and you have a trig, you have to think of the perspective of that angle measurement. So for example, here is this theta, you guys. Now, remember, sine is opposite over hypotenuse, but you have to be in the perspective of the angle measurement. So in the perspective of this, in that angle measurement, opposite would be this one. So this is your opposite. In the perspective of this angle measurement, the adjacent side is this one. And in the perspective of this angle, the hypotenuse is always going to be that one. So this is the hypotenuse. So I always taught my class, you guys, whenever I did trig, is always identify which one's your opposite, which one's your adjacent, and which one's your hypotenuse. And then that will tell you which trig identity you have to use in order to solve. You guys could talk or you guys can chat. Does anyone have any questions about that? Or do we all feel decently okay? I actually need to get you guys emojis to use so that it's a good way of understanding. But does anyone have any questions or whatnot? I think that means I understand.
Wait, can we talk? Oh, I don't.
Yeah,
Oh,
what's up?
oh, nothing, nothing. I was just saying no, nothing.
Okay. Everyone looks good. Everyone's giving the thumbs up. Okay. Well, you guys will have a chance to do a doyo too. Okay. So here's example one. Okay. So we're going to solve using our trig identities. So we have this big triangle and now you should, you guys should label which one's opposite, which one's the hypotenuse, which one's the adjacent. So that tells you which trig identity you can use to solve for this angle measurement. So in the perspective of this angle, right? This side is opposite this side is adjacent to that angle measurement, and the one across from the 90 degrees, that's always hypotenuse. Okay, now here's the question. In this problem, where is their information at? Well, there's information at the letter A, right? And there's information at the letter H. So when you guys look at your options, which trig identity uses the adjacent side? Which trig identity uses the hypotenuse side? And correct, Turner, it is cosine, because you guys see that one uses adjacent and hypotenuse. So now we can set up our equation to solve. So cosine of theta is equal to adjacent, which is 12, and hypotenuse, which is 13. All right. Now we still have to calculate this, so we have to isolate that theta. So that means this is in the way. That isn't that word COS, that cosine word is in the way because we need to isolate that theta. So this is how you guys have to solve for this. You have to take cosine inverse of both sides. So what cosine inverse does, you guys, remember, if you recall inverse from before, inverse undoes whatever the function does, right? So cosine inverse, these are going to cancel. So then we just have theta is equal to cosine inverse of 12 over 13. Now on your guys' calculator, how should I go about this? Well, I have a graphing calculator. Some of you have a normal calculator, but does everyone, so I'll just look at my screen. Okay, does everyone see this cosine? So do you see on the background, it says that cosine to the -1. So that's what you guys have to use in order to calculate cosine inverse. Cosine to the -1, you guys, is pronounced cosine inverse. So all I have to do is collect second, and then you'll see on the screen, and I have to do cosine inverse, which is right there. Did you guys see on the screen? Cosine inverse, and then you gotta do 12 over 13. And make sure you are in degrees. Make sure you are in degrees. So on your calculator, make sure you're in degrees. So you guys should have gotten 22.6 around, 22.6. So back to the main menu. It's going to be roughly 22.6 degrees. Okay. All right, next. Okay, example 2. So, okay, so remember, we have a right triangle. Now we have to be in the perspective of this angle measurement, right? So in the perspective of that angle measurement, this side is the opposite. This side is adjacent. And this side is hypotenuse. So now you'd have to think, right? Okay, we labeled everything, so where's their information at? There's information at A and there's information at H, which means that it's this one again is cosine. So cosine theta is equal to 4 over 5. Adjacent over hypotenuse, SOHCAHTOA. And then we have to solve for that theta. So in order to eliminate that cosine, we have to take the cosine inverse to both sides. So these are going to cancel. So theta is equal to cosine inverse of 4/5. Put this into your calculator. So cosine inverse of 4/5. So cosine inverse of 4 divided by 5. If you guys take a look at my screen, cosine inverse of 4 divided by 5. And you should have gotten 36.9 degrees. Yeah, Turner. Round to the nearest tenths. How do you change it to degrees? It depends on your calculator, Daisha. Don't have it. I don't have it offhand at the moment, so I'll probably have to take a look at that later, especially for oh, if you're using a graphing calculator, Daisha, um, on your graphing calculator, Daisha, you just click mode and then it'll pop up like different options and then it'll say degrees because I know you have a graphing calculator. Okay, so there's that one. All right, here's a doyo for you guys to do. So I would certainly try these out. I think this is a good time for you guys if you have any questions in terms of how to calculate cosine inverse, tan inverse, or sine inverse on your calculator or phone, because you can certainly calculate this on your phone as well. So I'll give you guys I'll give you guys like 2 or 3 minutes. Try it out and then see what you guys can do. And then yeah, come in the chat or talk to me if you have a question about this. But I'll set a timer for like 3 minutes, you guys, to you guys try it out. No, Jeremy, this is not mandatory. This is if you want to have a better learning experience or you feel like, you want to spice up your learning experience in math, but this is not mandatory. Kai, I think our third exam and final are going to be the same. So there is going to be a final test, but I still have to talk to the math department about it. One more test, Mariah. One more test, and that's it. Grades are not updated, Kim, because there is still one student that didn't take the test, but well, I'm gonna input it in today anyways because it's been a while, so the grades should be due by the end of today, Kim. All right. I will display to you guys how you went about this doyo. So, oh, you're welcome. So essentially, remember, okay, in the perspective of this angle, right? This side is the opposite, this side is adjacent, and this side is the hypotenuse. Okay, so that means there's information at an O and an A. And in SOHCAHTOA, right, in SOHCAHTOA, that is tangent. So tan of theta is equal to opposite, which is 4, over adjacent, which is 5. To solve for theta, take the tan inverse to both sides. These are going to cancel. So then you're just left with theta is equal to tan inverse of 4 over 5. So in your calculator, once you guys do tan inverse of 4 divided by 5, it is 38.7 degrees. And that's your final answer for that. Okay. For the next one, in the perspective of this angle, this one's opposite, this side's adjacent, and this side is hypotenuse. So that means you have to use sine, because sine uses opposite and hypotenuse. So sine theta is equal to 7 over 16. To get rid of this sine, take sine inverse of both sides. These cancel. So you're left with just theta is equal to sine inverse of 7 over 16. Submit that into your guys' calculator, and you guys should get 25.9 degrees. And that's about it. Any comments or concerns from you guys about that? Write in the chat. Write in the chat. Okay. Okay. All right. So, oh, your calculator. Gina, once I'm done recording like the actual lesson part, I'll help you with the calculator part because it depends on the calculator. Yeah. Okay, we just have 2 more examples and then we are done. So in example 3, okay, so this, you guys, is like almost the same thing, except now you have to find a side length instead of an angle measurement. So it's pretty much the same thing where we have to locate the angle measurement and be in the perspective of that angle measurement. So we have to be in the perspective of that angle measurement. So in that perspective, this side is the opposite, this side is the adjacent, and this side is a hypotenuse. So that means there's information, there's a variable at O, and there's a letter at 5. So we have to use O and A, which is tangent. So we got tan of 50.1 is equal to opposite, which is x, over adjacent, which is 5. And then we just solve right here. So in order to solve, I recommend you guys do the put this over 1 and cross multiply. So I would cross multiply this. So 1 times x, you guys, is just x. 5 times tan 50.1 is just 5 tan 50.1. So plug in on your calculator, use tan 50.1, calculate that, and then multiply it by 5. And your length, you guys, should be around 6.0 for that one. So tangent of 50.1, calculate that, and then multiply it by 5. And then lastly, example 4. Okay, so in the perspective of this angle measurement, right? This side is opposite, this side's adjacent, and this side is hypotenuse. There's information at O and H, which means you have to use sine. So sine of 25 is equal to opposite, which is 5, over hypotenuse, which is x. And then from here, you guys have to cross multiply. So put this over 1, cross multiply. So we get 1 times 5 is 5, and that's equal to x times sine 25, which is x sine 25. Now remember, you're trying to solve for x, right? So if you guys are trying to solve for x, you have to isolate x. So that means we need to get rid of that. So we have to divide both sides by sine 25. So you got 5 sine 25 is equal to x, and now we actually have to calculate that. So 5 divided by sine 25. And this, you guys, is going to be roughly around 11.8. So we are going to get into more trig type stuff for the rest of the school year. I put a calendar up for you guys so that you guys can see what to expect in the next 2 weeks. But we're pretty much ending our semester getting into this trig stuff. So this is kind of review, but I'm sure for many of you kind of forgot about this. And that's about it for this very first live streaming. Woo, we did it. So I'm gonna stop the recording now.